What's good, guys? Welcome back to another video. Today we are going to be going over some questions that I got from a pre-calculus student of mine, looking mainly like stuff with polynomials, more importantly quadratics, more importantly the maximization side of things, and a little bit of sketching of graphs. Just a few questions. So without further ado, just get right into it. All right. So the first question here is going to be sketching the graph. I was given kind of a weird graph here. Looks like f of x is equal to negative 2x cubed plus 6x squared minus 9 halves x. Okay, so when it comes to sketching a graph, what we need to recognize is that this isn't supposed to be perfect, right? My main goal isn't necessarily to get everything perfect. It's just to kind of get what the characteristics of the graph are. So in other words, I want to get the general direction, right? The end behavior, in other words, as we're going towards the left side of the graph, as x is going to negative infinity, are my y values increasing or decreasing? And as we're going to the right side of the graph, as x is going to positive infinity, are my y values increasing or decreasing? I probably also want to know my x-intercepts. Maybe are there bounce points, right? Once it hits the x-intercept, does it just kind of bounce off or does it go straight through? Maybe my y-intercept as well, and that might be something I want to know as well. Things of that nature, right? As long as I have a good understanding, that's all I need to sketch the graph. It doesn't need to be perfect. And pre-calculus here, we're not looking for absolute maximum or absolute minimum values for polynomials, anything like that. So that's basically what we're going to be doing. So the first thing I'm looking here is, well, I notice that this term is degree 3, right? Which means that it's odd. And so the end behavior is going to be up, down, or down, up, right? So in other words, as x is going to negative infinity, it's either up or down, and then vice versa for the other side. So how do I know which one is which? Well, the next thing I'm seeing here is that it's negative. Well, negative is telling me that, hey, this thing usually goes down, up, right? So starts down, goes up from left to right, just like a book. Well, in this case, since it's negative, it's going to be the exact opposite, which means it's starting up, going down. So it's going to be kind of weird doing this on a whiteboard, but essentially I know that the graph is going to look something like that. Now, I don't know exactly where these points are at or anything like that whatsoever, but I do know these basic ideas. All right, it's a little bit better. All right, so now that I know that, next thing I'm going to be trying to find here is my x values, my x-intercepts. So when do you find that? Well, x-intercepts, all these points right here, are when y is equal to 0. So what I'm going to do is essentially I'm going to factor this thing and set my x value is equal to 0. Well, I'm looking here, and each term has an x, and I don't really like this half, so what I'm going to do is I'm going to take it out. So in that case, if I take out 1 half x, we can even take out the negative actually. Well, that's going to leave 4x squared minus 12x plus 9x. Oh, 9. Sorry, not the x. Okay. So now here's my new graph. In other words, what I did is I just divided 1 half and x out of this whole entire thing. So now what I have to do, well, I have to factor this thing. So 4 and 9, what multiplies to 49? Well, 36. And what multiplies to 36 but adds to negative 12? What multiplies to 36 but adds to negative 12? What do we got here? I'm looking 1 and 36, 2 and 18, no, 3 and 12, no, 4 and 9, no, 6 and 6. Okay, so in other words, 4x squared, actually, never mind. Just notice that. Notice that the fact that my terms are both 6 means that this is in fact actually a binomial squared. So I can rewrite this as 2x minus 3 squared. And how do I know that? Well, first of all, the fact that I just split up the middle term into two numbers that are the exact same, 6 and 6, was my first indication. The second thing is the fact that 4 and 9 are both perfect squares. And also, in this case, if I divide negative 12 by 2 and square it, it gives me 36. Again, that just kind of makes sense, the fact that I had to split out into 6 and 6. These are all indications to me that this is a binomial square. And you can even see it here. 2 times 3 is negative 6, times 2 is negative 12, negative 3 squared is 9, 2 squared is 4. This is how it factors out. So then from here, what I'm doing is I'm setting these both equal to 0. So negative x, 1/2 x is equal to 0. Well, if I divide both sides by negative 1/2, the same thing as multiplying by negative 2. So x is equal to 0. So in fact, now what I can do here, let me actually get my other marker. Actually, I don't want to because then it's going to jack these markers up. I'm just going to put a point here somewhere of my x-intercept is 0. Okay. The other one is here. If I set 2x minus 3 equal to 0, I add 3 on both sides. That gives me 2x equals 3. Divide by 2, and I get x is equal to 3/2. So in other words, I have my second point somewhere around right here. And the fact that it's squared, again, anytime your binomial is even exponent, right? That means it's a multiplicity of 2, which means it bounces. So more specifically here, what I can say is that it probably comes down somewhere. Let's just say this is 3/2. Let's just say for now, this is my point. It might go something like this, bounce off of this, and then go back down. All right. So what else do I need here? I got my x-intercepts. I know that this one's a bounce point. I know that this one passes through. The reason why it passes 2 because x is to the first power. So it is odd, which means it goes through it. What else do I need? Well, what I need is my y-intercept. So in order to find your y-intercept, you plug in 0 for x and you solve for y. If I plug in 0 for x here, notice that my y value is also going to be 0. 0 plus 0 plus 0. So in other words, it does go through the origin, giving me my final graph looking something like this. And that's basically it, right? That's the sketch. There's nothing else that we can really do here. Calculus is something that teaches you how to find this point right here. But for now, we're all good. So you know what? We're on to the next one. All right. These next two I got going on for us are two word problems here. So I'll just read this first one. A small theater has a seating capacity of 2,000. And the ticket price is $20, attendance is 1,500. For each $1 decrease in price, attendance increases by 100. So the first thing it's asking us is write the revenue R of the theater as a function of the ticket price X. Okay. So let's kind of go through everything that's providing us. When the ticket price has a seating capacity, okay, so I'm going to write all this stuff here. It has a cap of 2,000. All right. The other thing that it provides us is the ticket price is $20. So I'm going to put T is equal to 20. Actually, I think it said that it wants it as X. So X equals 20. All right. And at this point, when X is equal to 20, our attendance, let's just say that's Y in this case, is equal to 1,500. And in this case, for each dollar decrease in price, attendance increases by 100. Okay, so I'm going to put just $1 down, Y up 100. All right, so this is everything that was given to us. So, in other words, we have to kind of figure out what this whole thing is equal to here. So, first things first is asking us what is revenue. Well, what is revenue? Revenue is equal to price times quantity. Right? In other words, if you sell 100 tickets, they're 20 tickets each, or, well, you sell 100 tickets, they're $20 each. Another made you made $2,000. How do you do the math? 100 times 20, right? That is what revenue is. So, well, we know that price is equal to X. So, again, math is a language, right? So all I'm doing is translating here. Revenue equals price times quantity. I know that my price is equal to 20. Well, not 20. Let's leave it as a variable for now because it is fluctuating. So price is equal to X. All right, so now what we got to figure out is what is quantity? Well, quantity here, or in other words, attendance, is the 1,500. So let's just kind of write this out. So times the 1,500 people. And then there's this other portion of this attendance, which is the fact that it, for every dollar decrease, Y increases by 100. So how do I show that? Well, in other words, X is my adjusting value, right? So anytime this decreases, so plus 20 minus X, Y 20 minus X, because every time this value decreases, I have to represent that somehow. How do I do that? Well, I know that my set price here for X is equal to 20. So it's 20 minus whatever the decrease is in the price. Then we multiply that times 100. And that right here gives us our equation. So let's kind of translate this. This is whatever the price is times how much we have in attendance at $20 plus whatever decrease we have in the price multiplied by 100 to represent the fact that our attendance increases 100-fold every dollar decrease. So now what do we do with this? Well, let's simplify. So what I'm going to do here is I'm going to distribute 1,500 times X. So that's 1,500X. And then let's distribute here, 100 times 20, well, that is 2,000, so plus 2,000x. That simplifies now to 13,500x. And then negative x times 100 is negative 100x times x, and negative 100x squared. And essentially, this is my revenue formula with respect to my x. There you go. So now we got the equation. So part one, complete. So let me read what part two was here. Okay, what ticket price will yield a maximum revenue? What is the maximum revenue? Well, now what we're going to be doing is we're going to be having to find the max, right? How do you find the max of an equation? Let me kind of erase all this stuff here. The maximum of equation, well, it depends on how we're using to solve it. Notice that the equation that we just got was a parabolic or quadratic formula, right? It was a quadratic equation. So what's the maximum value of a quadratic? Well, that is the vertex. So that's what we're going to be solving for. We have negative 100x squared plus 3,500x. So how do you find the vertex of a quadratic? Negative b over 2a. So in this case, it's going to be negative 3,500 over negative 200. It's positive 17.5. So what is this? Well, this is my x value, 17.5. In other words, the ticket price that yields the maximum amount of attendance. And then how would I find how much revenue I make? Well, I would just simply plug that back into the equation. And that is all calculator stuff, yielding us a total return of, in this case, $30,625. And that's how you solve that one. On to our final one. Okay, this one's pretty interesting. A Norman window is constructed by joining a semicircle to the top of an ordinary rectangle window. See figure. The perimeter of the window is 16 feet. Write the area A of the window as a function of x And then what dimensions will produce a window of maximum area? All right. Well, there's some stuff that I need to draw here for you guys in order for you to better understand what I'm looking at, which is this. First thing that I'm going to do is the perimeter of the window is 16 feet. So let me just write that here. Let's just say P is equal to 16 feet. Now the next thing I'm going to do here is I'm going to actually draw this thing out. So it looks a little bit something like this. On the diagram, it says that this is X, this is Y, and it looks like it wants to give us a radius here. It has it right here. It looks like it goes to the middle of X over 2. So now, well, the first thing that I'm thinking of is, well, I'm trying to find the maximum area at some point, so I'm going to have to make this an area formula. But everything's given to me in perimeter. So what I'm assuming is I'm probably going to have to use the perimeter formula, make these like variables all in terms of one singular variable, and then plug them into an area formula. That's kind of like where my idea is right now, so let's just do that. Well, let me think here. The perimeter is the measurement of the outside. So the first thing I'm thinking is well, this right here is completely and utterly irrelevant. I don't care about it whatsoever. I just care about the outside here. So basically, just this thing right here. Okay. Well, I know then that the perimeter of this rectangle here is just going to be X plus 2Y. Because there is no other X side. So it's not 2X plus 2Y here. So I only have 1. Right. Well, now I need to find the perimeter or the circumference of a semicircle. Well, I know that the circumference of a circle in general is pi times diameter. Well, I'm given a radius. So if the radius is X over 2, I know that the diameter is X. Because all a radius is half of diameter. So if I multiply it by 2, 1/2 times 2, that equals X. That's my diameter. So in other words, pi d. Okay, but here's the thing. For one, maybe I want to leave it as 2 pi r here. And the reason why I want to leave it maybe as 2 pi r is because it's in radius, but neither way, it doesn't really matter, right? The circumference is going to be just X times pi. Okay. But the problem is that this is an area of, or not an area, perimeter of a semicircle. So it's got to be half of it. So instead of that, I'm just going to do that divided by 2. So in this case, plus pi x over 2. All right. And that is my perimeter formula. Okay. But it wants the area. So the area is going to be a little bit different here. Let's just kind of write this area formula out right now. The area formula is going to be, well, the area of this rectangle, which is going to be x over y, plus, well, 1/2 again, right? Pi r squared. So pi times our radius of x over 2 squared, all divided by 2. But the problem is this. Why? The reason why y is the issue right now is because I need to be able to solve this somehow. And in order for me to solve this, I need all of my variables to be the exact same. I can only solve for one variable at a time. I can't solve for 2 at the same time. So what I'm going to have to do here in this case then is I'm going to have to solve for y. How do I do that? Well, I was provided p at the beginning of this, right? I know that for a fact that p is equal to 16. So I can plug that into this equation. Let me erase this for now. So that gives me 16 is equal to x plus 2y plus pi over x divided by 2. Okay. Well, now from here, what I'm going to do is I'm just going to solve. So I'm going to subtract x and subtract pi over x divided by 2. So 16 minus x pi over 2 is equal to, in this case, 2y. Well, now what I'm going to have to do is I'm going to have to divide everything by 2 here. I think it might be easier in this case to multiply it by 1/2. I'm seeing a lot of things that might be able to reduce themselves easier here if I just multiply this by 1/2 instead of dividing by 2, which is the same thing. It just looks a little bit cleaner to me. 1/2 times 16, that's 8. Negative x times 1/2 is just negative 1/2 x. And then 1/2 times negative x pi over 2 is just negative x pi over 4. That equals y. Well, now from here, my next step here is I'm going to plug it back into that area formula that I got just a little bit ago for my y value. So, like I said, area, let me actually delete this top part here too. Dang, dude, erase. Jeez. I'm deleting everything on a whiteboard. That's crazy. Okay, so area is equal to x times 8 minus 1/2 x minus pi over x over 2 or 4. Whoops. And then the next part was the area of this, so plus, what was it? Pi r squared, so pi times x squared over 2, all this divided by 2. Well, now what I have to do here is I have to simplify. So here comes all that algebra stuff. This is going to be 8x minus 1/2 x squared minus pi x squared over 4. Okay, plus pi, and then this is going to be x squared over 4 divided by 2. Now, let me just start simplifying further here. Well, pi over x squared divided by, what did we have? We had pi times x squared over 4 divided by 2. Well, that's the same thing as multiplying this whole thing times 1/2. So in other words, I can rewrite this as pi over x squared divided by 8. All right, now we're getting somewhere, right? We're making progress here. So now what I'm probably going to do is I'm probably going to try to combine as many things as possible here. I'm seeing a lot of things that have are divisible by 2 here, or divisible by 8 even. I can get a common denominator of 8. So let me try to rewrite all this as 8x minus, what would that be? 4x squared over 8 minus 2 pi x squared over 8 plus pi x squared over 8. Okay, so that all ends up equaling 8x minus, well, these can actually combine, so I'm going to get minus 4x squared minus pi x squared all over 8. Okay, and then I get 8x minus 4. Oh, I can even take out x squared here. 4x squared. Not take out the 4, just kidding. I can take out x squared. And I'm left with 4 minus pi all over 8. Actually, my bad. This is going to be, in reality, this minus is connected here, so I can factor out the minus, which is why that's there, and this becomes plus. So this is actually going to be plus here, right? Because notice how all these terms are negative, so what I could do is I could factor out, which would bring this minus here, and then I'd get this right here. And I think that's everything that we can do with this. Because now, I got to find the max. So how do I do that? Well, let me rewrite this equation to make it make a little bit more sense. I'm trying to find the maximum, which, just like last time, I got to find the vertex. Well, notice that this is negative 4 plus pi over 8 x squared plus 8x. This is starting to look familiar now, huh? So the reason why is now I have it like this. So what can I do here? Well, what I can do is I can rewrite this as negative 8 over 2 times negative 4 plus pi over 8. All right. So then from here, what would I have to do? Well, what I have to do is simplify here. So let's think, what can I do? I can distribute, that gives me 2/8 on the bottom. So let's just say negative 8 over, let's just say 2/8 negative times 4 plus pi. Well, how do you divide by a complex fraction? You multiply by the reciprocal. So in other words, I'm multiplying this by 8 halves, negative. Well, that's going to be 64 divided, that's going to be 32. So all this ends up equaling 32 over 4 plus pi, which is equal to roughly 5.62 feet. All right, well then from here, all I'd have to do is I'd plug that back into my y value equation, which was 8 minus x over 2 minus pi x over 4. All right, so now I got my y value here. This is essentially what we got after taking the formula for the perimeter and solving back for y. And then what I'm going to do is I'm going to plug this new x value that I got here. This is essentially what my x dimension is equal to here. And so I'm going to do the same thing for my y value and then see what I get. All right, so now that I have my x value and I know my y value in terms of x, well, I'm just going to simply plug in. That's going to be y is equal to 8 minus 1/2 times 32 over to 4 plus pi minus 1/4 pi times 32 and then 4 plus pi. All right, now from here I'm just going to simplify. So this is going to equal 8 minus 16 over 4 plus pi. And then here this is going to be equal to minus 8. So minus pi, or 8 pi over 4 plus pi. But what I can do is I can give all of these a common denominator of 4 plus pi, specifically multiplying the 8 by 4 plus pi. So let me rewrite that up here. That's going to be 8 times 4 plus pi minus 16 minus 8 pi all over 4 plus pi. If I multiply out, that's going to give me 32 plus 8 pi minus 16 minus 8 pi all over 4 plus pi. Well, look at that. 8 pi, negative 8 pi, these are going to cancel out. 32 minus 16, the answer for y is equal to 16 over 4 plus pi, as well as our x value here equaling 32 over 4 plus pi. And that gives me my dimensions for this thing. My x value has to be this. My y value has to be this. If I plug it into that area formula that we got in the beginning, that xy plus pi times x divided by 2 squared, it would give me my area maximized for this considering those dimensions. Whew, that was a lot. Regardless though, thank you guys for watching. I hope this helped. If you have questions kind of similar to this, or not even similar to this, it can be anything, always feel free to drop them down in the comments. If you're looking for more upfront and close and personal one-on-one tutoring, if instead you're looking for something like some tutoring, upcoming test, or just want to get better with your math skills, always feel free to head on over to mindlooptutor.com. Until then, I'll see y'all next time. Take care, and as always, peace out.